And by now you are familiar that there are two ways of representing the game. One is normal form game that we did in the last week, and in the last class itself we talked about extensive form game. So, let us take a game that you are familiar with and just revise it quickly, because this is such a fundamental game. So, we have two suspects, Ranga and Billa, they are held in separate cell. Ranga is represented by R and Billa is represented by B. The inspector Vinod has enough evidence to convict each of them for a minor crime, let us say 1 year in jail, but not enough evidence to convict either of them for major crime, let us say that gives them 20 years in jail, unless one of them confesses. If one of them confesses, then it becomes certain that they were involved in the crime and one of them would get 20 years. If both confess, both get reduced sentence of 5 years only. If only one of them confess, the confessor gets to walk free, because he has become government prosecutor's witness, government witness. So, no punishment for him, but the other goes to jail for 20 years, and we have already seen the way to represent. So, this is representation of prisoner's dilemma done by Encyclopedia Britannica, used to be a very famous encyclopedia before Wikipedia and Microsoft Encarta came into picture. When we talked about the game tree, we said that one event happens after another. So, if we say that Ranga is deciding first, here Ranga is deciding to confess or Ranga is deciding to remain silent, and we just do like this, that Billa is deciding here, Billa is deciding here to confess or remain silent, to confess or remain silent. What is happening? At this point, Billa is aware that Ranga has confessed, because Billa can see, look in this direction and see, because this situation has reached, because Ranga has confessed. And here Billa has decided to, Billa has to decide whether to confess or remain silent, but Billa sees that Ranga has remained silent. So, it will change his strategic behavior, that we will learn later, that how it is changing through example we will see, but we do not have this situation. Billa does not know what Ranga has decided and Ranga does not know what Billa has decided. So, we can do here the dash line to indicate that Billa is not able to distinguish between this node and this node. Billa knows that it is his turn to move, but whether he is on this node or whether he is on this node is not clear to him. The same game can be represented, of course, if they both are confessing, they both are getting -1 year. Ranga is confessing, going to walk free, Billa gets 20 year, here 20 year, 0 year, and here if they both remain silent, then they are going to get, sorry, here it will be -1 and here it will be -5. This is the situation we have. Nothing would change if we say that Billa moves first. So, Billa decides here to confess or remain silent, and then Ranga decide to confess or remain silent. We can say again here Ranga does not know whether he is on this node or he is on this node. Okay. And again, so I can say the both situations are strategically the same. Typically in such situation, one thing you have to keep in mind, because Ranga is moving here first. So, by convention the first payoff is to Ranga and the second payoff is to Billa. So, therefore, now we will have to be bit careful, that because Billa is confessing, but again the first payoff is to Billa in this case, and therefore, we were right in the beginning also. Okay. First payoff is to the player who moves first if it is not clearly indicated. Good practice is to very clearly indicates that where payoffs is given as x comma y, x is the payoff of Billa and y is payoff of Ranga in this particular game. Then there would not be any confusion. So, you have to be clear about it. So, such thing, as I have already indicated, this is called game tree, because this is the root, its initial node, game is starting here, these are like branches. So, it is like tree structure, and that is why we call it game tree. Something that we have to keep in mind, that whenever we have a game tree, we should have only one initial node. Situation cannot be like this. Here it is clear that game is starting either here or here. Such situations are not allowed. So, this is not a possibility. Okay. So, let me erase this, this is not a policy. There has to be only one initial node, game has only one beginning point. Now, there is no cycle. What do I mean? So, game has one initial node. Now, let us say it is starting like this and then it comes like this. So, here what will happen, this terminal node can be reached in two ways, that game is starting here, then it is proceeding in this direction and reaching here, and it is starting in this direction and it reached to the same point. We can see that there is a cycle here, this is the cycle. What do I mean by a cycle? That you can start on one node and then you have to move to another node through a branch like this, and you can come back to the original initial node without going to the same branch twice. So, here like this, it is the movement, you can come back here. Direction does not matter if we if we describe it like this. So, this can be called a cycle. So, no such cycles are allowed in game tree. If we extend it further, what we mean to say is that there is only one path from one initial node to terminal node. Here in this example, what is happening? If you pay attention, so this terminal node can be reached in two ways, and this is one way and another way is this way. This is also not allowed. There has to be only one path. So, such trees are allowed because you move here, this is the way you reach to terminal node, there is only one way, there is no other way to reach to this terminal node. So, when we are drawing the game tree, we have to keep in mind these three things, that only one initial node, there is no cycle, and there is only one path from the initial node to the terminal node. Now, in the last week, I talked about rules of the game from art perspective. Let us why art is also important and why science is important. We cannot get into the details of it, but art comes from practice. Science is typically rule based. So, we can describe what are the rules in a very precise manner. In art science also we can call them rule, but they are not so precise. One has to do some sort of approximation, some sort of thinking. Here in the straightforward manner, we will talk about what are the rules of the game. So, when we are talking about a game, it is certain that we have a strategic environment. What do we have in this strategic environment? We have players or decision makers. In fact, we are calling these decision makers players. You will pay attention that some points are written in black and some points are written in blue. The points written in black are universal, whether we have normal form game or extensive form game, we will have these rules applicable all the time. But the rules written in blue color here, this one and this one, it is required only in the case of extensive form game, we do not need them in case of normal form game. Let us talk about them one by one. So, we have already discussed that who are the decision makers, we call them player. Who moves when? This is important in extensive form game. Extensive, as the name indicate, it gives all the detail, while in normal form game or strategic form game we omit certain details. So, who moves when is not important in the simultaneous move game, because we assume all the decision makers, all the players are deciding simultaneously. When they are deciding, they do not know what other players have done. That is not the case in the extensive form game. In extensive form game, it is important to describe that one player moves after which particular move. All the details would be required there. Then the next is, what are the strategies available to each player? Like in the normal form game, in prisoner's dilemma game, we have discussed that the two strategies for each player. The war game that we discussed earlier can have army 1 attacking or deciding not to attack, and army 2 deciding to fight or to surrender. These are the strategies. One thing I would say, that there is a huge difference between strategies and action, at least technically. So, we are going to spend some time talking about them. Next thing is, how much does one know when it is her turn to move? This is already answered for the simultaneous move game or normal form game. In these games, players do not know anything, but in the war game that we discussed, that army 1 is deciding to attack or not to attack, and then army 2 is deciding fighting and surrendering. In this particular case, army 2 knows, if army 2 is at this node, army 2 knows that army 1 has already attacked. So, this informational structure, and we are again going to define this informational structure in detail little later. It plays very important role. And then what are the payoffs? The number typically that we write on the terminal node would indicate the payoff. Typical objective for all the players are that they are interested in maximizing their payoff. What are the rules now? Rules is timing of moves. So, one thing is very clear, whether it is simultaneous game or it is sequential game, we have already discussed them. What is the nature of conflict and interaction? Whether these players are interacting only once and going their separate ways, or they are interacting again and again. When they are interacting again and again, then it matters how do they behave in previous game. Okay? There is a strategic consideration that shadow of the future can influence your decision, but right now for time being we will focus on only one time interaction. Later on, probably in 5th 6th weeks, we are going to talk about what happens in case of repeated interaction. You know, repeated interaction helps players build certain reputation, and these reputation can help them achieve better outcome, but for time being we will not talk about it. What are the informational condition? When we were talking about asymmetric information, adverse selection, we talked about that, you know, acquirer may not know the actual valuation of the company. So, the valuation, if you know, you would behave differently. If you do not know, your behavior would definitely change. So, information plays very important role, and later on we are going to bring them into consideration. And the last point is enforceability of agreements or contract. If prisoner's dilemma game, Ranga and Billa, they have made a pact, and that pact is already given to, you know, this pact is made in front of a godfather who would be very angry, very unhappy if one of them breach the contract terms. So, then of course outcome is going to be different. For time being, we are going to assume we are interested in only self enforced contract. The contract, there is no outside agency backing that contract. So, like in prisoner's dilemma, we have already discussed earlier that if there is no outside agency, they both would end up confessing and they both would go to jail for 5 years instead of going to jail for only 1 year, which would have been better for both the players, but that is not the situation here. Similarly, formal representation in extensive form game, we have already learned that we can draw a tree. We can draw a tree and we can describe. But again there are many situations when this tree would not help. Let us say that each player has infinite number of strategy. There are many players. How can we draw tree? Even sometime, even if we are able to draw the tree, it would become very cumbersome looking. It may look very complex. So it is not that good idea. So what is the mathematical way of representing? That is the formal way of representing. You list all the player. The next thing is player function defined on history. What do I mean? So let me draw this prisoner's dilemma game, and let us say Ranga is starting here. Here is Billa who doesn't know. We can say here confess, do not confess, confess, do not confess. So now first thing that we need to define is called history. What is a history? History is basically a sequence of path that takes game from the initial node to a terminal node. So what are the history possible? We can say C comma C is a history possible. If you want to add, you can also say that here Ranga is deciding C and here Billa is deciding C. But you do not need to mention all these things because players are already listed, and once we say player function it will become clear. So C comma C, C comma D, D comma C and D comma D are 4 different history. Now what we can do from history, we can define something called sub-history, that is the subset of a history. So what would be the subset of this history? Phi. If we know the set theory, basic of set theory, an empty set is a subset of all the set. Another is C and third is C comma C. Similarly here is phi, C, C comma D, and here we will have phi, D, D comma C, and here we will have phi, D and D comma D. So basically we need to define player function at phi, then we need to define player function as C or D, C and D, and then we need to define the player function at C comma C, C comma D, D comma D and D comma C. So one thing we should say that we do not need to define because here the game is ending, so we are not going to define. So we can modify this player function defined on proper sub history. You know what is the proper? That we should not be taking the full history because full history will take us to the terminal point, terminal node, and at terminal node game is ending, so no one is playing at that particular point. So player function is basically a mapping, is a function from proper sub history to list of players. So where we need to define? Here we need to define at phi, C or D. So we need to say who moves at phi. Phi indicates the beginning of the game, initial node. So at phi Ranga plays, at C Billa plays, and at D again Billa plays. That is the way player function would be defined. Again we will use 1 or 2 more examples where it will become clear. What are the action or strategies? As time being, Ranga has 2 action, C or D. Billa, because cannot distinguish between this node and this node, so the way Billa see it, that now it is his turn to move and he can take either C or D as an action. So Billa has only 2 actions, C or D. For time being, let us consider slightly different version of the game, that Ranga moves here and Billa moves then. What happens in this particular case? Notice that there is no dotted line. I am not drawing any dotted line. What does it mean? That when Billa moves, Billa knows what Ranga has done. So in this case, at this node Billa has 2 action, C or D. At this node Billa has 2 actions, C or D. But when we talk about Billa's strategy, and when we are talking about the strategy, we want to describe it at the beginning of the game. So, we can say Billa has in fact 4 strategies. What are those 4 strategies? Let me draw it here once again. Ranga, confess, do not confess. Billa, confess, do not confess, confess, do not confess, and we are describing here. So, for Ranga's strategies we can write C comma D. In this case Billa gets to observe what Ranga has done. So, Billa's action can be conditional on what Ranga is doing. So, Billa can decide one of these 4 things: confess if Ranga has confessed, and don't confess if Ranga doesn't confess. What this strategy is telling Billa, that if he find himself at this node, he should move in this direction, and if he find himself in this node, he should move in this direction. So, there are now 4 such possibility. Second possibility is that always confess, no matter what Ranga does. This strategy is simply that at this node move in this direction, and at this node move in this direction. So, it is different from earlier strategy. Half part they are the same, but anywhere there is a difference we consider it a different strategy. Third could be never confess. You can say here no matter what Ranga does. And fourth is that do opposite of Ranga. Here the first one can also be written as that take the same action as Ranga. Here do opposite of Ranga. So, in short we can say this is C comma D. It should be clear that this C is coming after Ranga has confessed, and this D is coming after Ranga has not confessed. So, this is C comma C, this is D comma D, and this is D comma C. So, these are the 4 different strategies that Billa has. So, now I hope you understand the difference between Ranga and Billa. You may be having a question that why do we need to describe a strategy in this particular manner. So, I will give you 2 answers. One is a cheap answer, that is that this is the way we do, but it does not explain anything. Why do we define strategies like this? That should become clear from later exercises.